In the last video, we learned how to write expressions that operate on numbers. That video should have given you a pretty good sense of how to write those expressions. In this video, we're going to look in more detail at the rules Racket uses to evaluate those expressions. Now, you may find it a little pedantic to talk about the precise rules for evaluating an expression like plus 1, 2. And if all programs were that short, you'd be right. But here's something to consider. The Chevy Volt has 10 million lines of source code in it, 10 million lines of source code in a car. So programs get quite big. If that was a program written in the beginning student language, it would have many more than 10 million expressions in it. And it turns out that in order to be able to understand big programs, we really need to understand the detailed rules by which expressions get evaluated. We won't always need to think in terms of those rules, but we do need to have them to fall back on. So that's what we're going to look at in this video.
Here's the expression that I'd like to work with. And if I just run this, I'll get the value 14. What I want to do, though, is look at the detailed step-by-step process that Racket uses when it evaluates this expression that results in 14. Before I do that, I want to introduce an additional bit of terminology here. We're going to say that an expression like this one, because it starts with an open parenthesis and then the name of a primitive operation, is called a primitive call, or a call to a primitive. And in a primitive call, we're going to say that this is the operator. And in a primitive call, we're going to say that all of these expressions that follow the operator, in this case there's 3 of them, are the operands. And of course we could do this same thing because there's another primitive call sitting right here. And inside that primitive call, that's the operator, and those are the operands. And I could do the same thing over here. So that's a bit of terminology. Now let's look at the step-by-step process that takes that expression and ends up producing the value 14. Well, the first thing that happens is Racket is asked to evaluate this entire expression. And it sees that it's a primitive call because it starts with an open parenthesis and a primitive operator. So the rule for evaluating a primitive call is that first all of the operands need to be reduced to values. Well, this operand, the first one, already is a value. So no evaluation work is going to be required there. It already is a value. But this operand is an expression. It's not a value. So some work is going to be required there. Let's look at that. Well, this whole thing is a primitive call because it starts with a parenthesis and a primitive operator. So let's look at its operands. Well, that first operand is already a value, so no work required there. And that second operand is already a value, so no work required there. So at this point, the 2 operands in this primitive call have been reduced to values, and so this multiplication can happen, and this whole thing is just going to become 12. So we'd say that in the first step of the evaluation, this whole expression becomes this. Now I've left some extra space in here that you wouldn't normally leave here just to make things continue to line up. But here we see that in the first evaluation step, that operand gets reduced to the value 12. Well, now we've reduced the first 2 operands to plus to values. We need to work on this third one. It's an expression now, it's not a value, so we need to work on it. Let's see. Open paren, the name of a primitive operation. This first operand here is not a value, so we need to reduce it. Let's see. Open paren, the name of a primitive operation. This operand is a value, this operand is a value. So at this point, this thing here, we can do the plus to get 3. So the next step of the evaluation is this. So that plus 1, 2 has now become 3. So again, we were working on these operands to minus. This one's a value now. This one already is a value. So this minus can happen to get 0. At this point, all the operands for that plus have been reduced to values, so that plus itself can happen. And the whole thing, of course, becomes 14. We'll learn more about the detailed step-by-step evaluation rules in a couple more videos. But for now, the intuition to take away from this is that evaluation of an expression in general proceeds from left to right and from inside to outside. So as we evaluate the outer plus, this times 3/4 happens first because we go left to right. But then when we try to do this whole expression, this plus 1, 2 has to happen first because of the inside to outside behavior, because all of the operands to that minus have to become values before the minus can proceed. That left to right, inside to outside intuition is an important way to understand the evaluation of expressions in the beginning student language.
Now you've seen the first evaluation rule, the primitive call rule, and you've seen how repeated application of that rule can evaluate numerical expressions of arbitrary complexity. You've also seen how repeated application of that rule leads to a left to right, inside to outside evaluation order. One of the great things about our beginning student language is that it actually turns out not to have very many evaluation rules. We're going to learn 3 more in the first week of the course, and then just 3 more the entire rest of the course. And that's going to let us write programs of arbitrary complexity. That's one of the reasons why we're using the BSL language. It lets us spend not very much time explaining the language, so we can focus more of our time on how to design programs. And that, the ability to design programs in any language, is really the most important thing to learn.